Good afternoon, everybody. Welcome to a rainy Monday afternoon at Chem 170 with your host, me, Dr. White. Hi, everybody. All right, important announcements. On this Wednesday, I will be giving test number 4, and you'll be able to download it as a protected PDF file. And after class on Wednesday, 4 p.m. or earlier, most likely a lot earlier, I will send out an email with the password for test number 4. You'll have until Thursday, 1 p.m. to finish test number 4 and upload it as a single PDF file to D2L. Should take you about 40 minutes to finish the test. If we were face-to-face, I give 50, but most people are done in 40. But last test of the semester, not the final last test, take as long as you need to complete it. Am I nice or what? Don't answer that. All right. Now, test number 4 will cover polymers, lipids, carbohydrates. It has 9 pages, 20 problems. Some of the problems are multiple part, and the point breakdown, general knowledge, 54, nomenclature, 15, reactions, 36. And it's got five bonus points. Now, why is there so much general knowledge? Well, I mentioned this before. If I ask you, is my right hand chiral or achiral? Chiral. Well, that's not nomenclature. It's not a reaction. So it's general knowledge. And a lot of the carbohydrate questions are what I lumped into general knowledge. I'll do a review today. Wednesday, we'll have our regular Zoom meeting and lab, the last lab of the semester. And please note, the extra credit project deadline is a week from today. No late projects. Remember, that's 10 bonus points. If you would like me to check your project before you hand it in, and I'll tell you what's wrong that you need to fix, email me it. Don't do it through D2L. And one of your colleagues already did. And I will tell you if it's right or what's wrong. So there should be no problem of you getting 10 bonus points. All right, another thing I noticed when I was doing labs, and I've caught up essentially grading labs, a couple of you are missing some labs, haven't handed them in, and it's past the deadline. Well, I'm offering a lab amnesty program. If you have not handed in a lab that's past due, I've opened up the labs in D2L. You'll have until Monday, 5/10/23, the 10th of this month. Oh, by the way, everybody, happy May Day. And to upload the finished lab. Now, since they are late, I'll take off 2 points. But if you get everything right, 9 points is better than 0. So if you haven't handed in certain labs, and a couple of you haven't, you'll have until the 10th to hand in the labs. After that, any lab that was not handed in will get a 0. Now, I would like all of you to check on D2L that if you have submitted a lab, it should be graded. If there's not a score for a lab you've submitted, unless you did it last night, and we're talking labs 1 through 10, please let me know via email. Actually, more than that. Other than the one due Wednesday and the last lab this coming Wednesday, I've graded everybody's lab. I think who's handed in, but if you haven't, look, email me what lab, and I'll look to see where it is, and I'll grade it. As I said, the first day of class, I don't walk on water unless it's frozen, and even then I stay off. In other words, I'm not perfect. I make mistakes. Oh boy, have I in my life. All right. One more special announcement. Everybody, are you listening? On Wednesday, I will have a special surprise for you. Deals with chemical plants. And I'll be showing you something, but I'll cut it out of video. So if you want to see it, do come to class on Wednesday. All right. Let's go through the review for test number 4. Let me move some stuff out of the way here. All right. You should know what is a polymer. And a polymer is a macromolecule, that means a huge molecule made up of repeating units called monomers. Now, when we talk about polymers, there's 2 types based on chemical property. One is an addition polymer, the other is a condensation polymer. I think I make this a little larger. That's better. And the addition polymer, you should know, is made with only one type of monomer. You should know examples of addition polymers. Rubber tires, saran wrap are 2. Next, condensation polymer. You should know that a condensation polymer is a polymer made with 2 different types or more of different monomers. An example of that, plastic water bottle or pop bottle, nylon jacket. Now, another way of classifying polymers that you should know is based on a key physical property of that polymer. And the first one is a thermoplastic polymer. And a thermoplastic polymer, you should know, once formed, it can be reheated and reshaped. And examples of that, my water bottle and saran wrap. There's no correlation between the chemistry of a polymer and its physical property. You got to go measure it. Now, a thermoset polymer, once formed, it cannot be reheated or reshaped. An example of that are rubber tires or the urethane foam on my office chair or in a couch or in a car. All right, now, next I talked about lipids, really fats and oils. What's a lipid? A molecule from plants and other living things that's soluble in nonpolar solvent, but not in water. And you should know there are 2 types of lipids. The first one is a saponifiable lipid that yields carboxylate anions of fatty acids in a reaction with base and water. And we call those fats and oils. Non-saponifiable lipids do not react with base and water, and those are steroids, hormones. Now, you should know the difference between a fat and an oil. A fat is a solid or semi-solid triglyceride at room temperature. An oil is a triglyceride at room temperature. And here I have the general structure of a fat or oil, 3 esters, just to remind, fat and oil chemists, otherwise known as, I just had a mind, let's see, not petroleum, fat and oil chemists write their ester like this. And various reactions that we learned for esters, you should know how fat or oil undergoes it. First one is acid hydrolysis of an ester. Remember, you have 1, 2, 3 esters, and they form these 3 alcohols, which is glycerin, plus these 3 carboxylic acid. Base hydrolysis of an ester, you learn for test 3, gives an alcohol plus the carboxylate anion of that ester. And for the fat or oil, again, you have your 1, 2, 3 esters, and you get 1, 2, 3 alcohols, and that forms glycerin because you don't break carbon-carbon single bonds, and you get these 3 carboxylate anions of the carboxylic acid you would have used to make those esters. Now, a new one I talked about, which I worked with when I was in industry, is called steam hydrolysis of an acid, fat, or oil. And here, remember, there are 2 ways of making a reaction go quicker. Add a catalyst, or for most, not all, but most reactions, increase the reaction temperature. And instead of hydrolysis of an ester with acid or base, use steam, hot water, increase the temperature of the reaction. And you get the same products as acid hydrolysis, the alcohol, and the carboxylic acid you would have used to make that ester. And here, once again, we have our 3 esters, and we get our 3 alcohols in glycerin. And I'll never ask you what's the name of that, but that's glycerin. And we get our 3 carboxylic acids. Now, the carboxylic acids we get from fats and oils are fatty acids. That's short for fatty carboxylic acids. And there are 2 structures I asked you to learn. One is stearic acid, which is a or saturated fatty acid. I'll explain what that is in a fat. And that's got the structure right here. And then there's oleic acid, which is a common name, and you should know the structure right here. And oleic acid has a double bond at C9. And notice I haven't done it all semester, but if you want to, you can write out 16 CH2s, or you can use the parenthesis method like I have. Same thing in oleic. Now, you should know, saturated fat contains only carbon-carbon single bonds. If you were to write down saturated fat, only single bonds, I'd mark that wrong because it has an ester, which is a carbon-oxygen double bond. It's only carbon-carbon single bonds. Now, unsaturated fat has at least 1 carbon-carbon double bond. Remember, Mother Nature never did triple bonds. Organic chemists created that, not Mother Nature. Now, since I worked in this industry, I'm teaching you stuff most organic instructors don't know. You should know that tallow is the name of the fat that comes from beef fat. Yellow grease and white grease are 2 different grades of fat, solid or semi-solid room temperature, from pig's fat. Now, to make this class interesting, I came up with how can you show tallow? Well, I have it written right here. For tallow, yellow grease, and white grease, this is a good approximation. R sub O is the tail. R sub S would be this. And R sub O, in my shorthand, which chemists use, oil chemists. I was thinking the name of it. Oil chemists are really fat and oil chemists, but not petroleum. And that would be R sub O. And to show tallow, yellow grease, and white grease mixtures, saturated, unsaturated alkyl groups, I use SOS. Remember that save our ship help. And therefore, you should know if I put down a test tallow plus reagents, what are the products? And if I have base and water, what 3 products? Remember, we're not balancing things in this class, chemical equations. And here you have tallow or white grease or yellow grease is really this designation right here. And here we have our 3 esters. We get glycerin, you get sodium stearate, sodium oleate, because base hydrolysis of an ester gives you an alcohol plus the carboxylate anion. And you should know the reaction of tallow, yellow grease, and white grease with acid and water, base and water, and steam, which were in the fat and oil or lipid problem set we went through before. All right, now, this is important. Leaving my class, you should know how soap works. You should know the structure of soap. Non-polar tail, polar head. You should know dirt and grease are polar, and I really should have down here water is polar. And the key to all this is like dissolves like. I should have written that a lot larger, which I did when I talked about it. Now, dirt being nonpolar will not attract water, but dirt being nonpolar, the nonpolar tails of soap are attracted to that. And this forms all around it. I'm just showing you a small segment. And you should know that's called a micelle. And now when you form the micelle, the outer around the dirt is all the polar heads of the soap. And water looks at micelle and says, micelle, you're polar, I'm polar, let's go down the drain together. And they do, and that's how you get your hands clean, your dishes clean, your clothes clean. I did a lot of laundry this weekend. All right, now, way back up here, non-saponifiable lipids, that's a steroid. And you should know how to draw the ring system for a steroid. There are 4 rings bonded together or fused together, 6, 6, 6, 5, in that position. All right, next I talked about carbohydrates. You should know, what is a carbohydrate? A polyhydroxyl aldehyde or ketone, or a molecule that upon hydrolysis becomes a polyhydroxyl aldehyde or polyhydroxyl ketone. Hydroxyl means OH, poly means many. Now, something that's important to all our organic chemistry, but I decided to hold off until this chapter, is the concept of chirality. And you should know chiral or chirality means handedness, like your hands. And when it comes to chirality, there are 2 types of objects. Achiral object. A means without chirality or handedness, and that's the object with a superimposable mirror image. I'll never ask you the definition of achiral or chiral, but you should know how to apply it. And we'll do that in a problem set later today. Next, chiral object. And that's an object with a non-superimposable mirror image. And your hands are chiral because if you put your right hand up to the mirror, you'll see your left hand, assuming I don't have the ring on, and they're non-superimposable. By the way, in case you forgot, what's that? A spider doing push-ups on a mirror. I couldn't resist, and I didn't. Now, when we talk about chiral molecules, it's important to have what's called a chiral carbon atom. And that's a chiral carbon atom with 4 different groups, 4 different atoms, or a combination of 4 different groups or atoms. I will never ask on a test or the final, that's coming up in a couple of weeks. Relax, people do really good on my final. Last week, you'll know why. All right, but you should know how to identify the molecule of chiral atom, and we'll do that in a problem set. Next, enantiomers. Enantiomers are molecules with a non-superimposable mirror image. Therefore, if I give you an enantiomer, a molecule, and ask you to draw the enantiomer of that molecule, I'm really asking to draw the mirror image. Ooh, no, this must be important. And For glucose, an important reaction that it does in itself called the intramolecular reaction. But here I show the intermolecular, which you learned for test number 2, aldehyde or ketone, alcohol, acid catalyst, you get a hemiacetal, hemiketal. In glucose on C5 is the alcohol, C1 is the aldehyde. And this reacts in an equilibrium. Since it's intramolecular, you don't need acid catalyst to form this cyclic compound. You should know how to do this. If I have glucose and put arrows and say, give the reaction product or product, you should be able to write this cyclic one. And because I didn't ask you to learn the Hawthorne ring drawing system, I came up with this idea. Remember, this oxygen is bonded to this carbon by the world's longest and ugliest oxygen-carbon bond, but that makes your life easier, which is a good thing. Now, this is glucose. Another key sugar or carbohydrate is fructose. And fructose undergoes the same type of reaction, except now at C2, you have a ketone, and still at C5, you have the alcohol. And again, it forms to this carbon. That's a carbon-oxygen bond. And that forms that cyclic one. Now, I taught you a variation of a new reaction, this one. And this is if you take a hemiacetal, hemiketal, and react it with acid and an alcohol, another one, you get an unsymmetrical acetal or ketal. Notice on the oxygens R and R triple prime are different. When I originally showed you for chapter on ketones and aldehydes, they were the same, used 2 alcohols. But sugar chemistry and Mother Nature can do like this. And here, if you have the cyclic form of a glucose right here, reacts with alcohol, and the only change is this becomes this. And that's important because that's how sucrose is formed. Glucose and fructose bond together. That's how starches are formed. Glucose molecules, and I showed you a couple, form starch. Now, key reactions, if you take glucose, a lot of them, and add acid, like an enzyme, you'll make starch. Now, this is important. The linkage that holds starch together is an acetal linkage. And when you add acid and water, like in your stomach, sucrose breaks down to fructose and glucose, and starch breaks down to glucose, which is why glucose is the most abundant, because you get your energy from carbohydrates like wheat, like rice, potatoes, the good stuff, French fries, pizza, from your body breaking it down to glucose. Now, leaving my class, at this point, there's 2 things you should know. Later today, I will talk about the 3rd thing that won't be on test number 4, but can be on the final. And I haven't been subtle, so it's time for Dr. White to be subtle. Even though I have it on the page. You should know how to describe when you eat a fat or oil, how to describe it with words and a general reaction. What's the key functional group in a fat or oil? A ester. And in your stomach, there's acid and water, so it's acid hydrolysis of an ester. The general reaction you learned for test number 3, ester, acid, and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. And that's how you do it. Again, for eating a fat and oil, you should know how to describe. See, it even says it on your screen. Oh, that was lame. Sorry. But anyways, but it's true. How to describe with words and a general reaction when you eat a fat or oil. Excuse me. What's the key functional group in a fat or oil? An ester. So you describe with words acid hydrolysis of an ester, and the general reaction is ester, acid, and water. You get back to carboxylic acid and the alcohol you would have used to make that ester. Now, you should also know how to describe with words and a general reaction what happens when you eat a carbohydrate. What's in your stomach? Acid and water. So it's acid hydrolysis of an ester. What's the key functional group holding glucose together in carbohydrates? And acetal. So it's acid hydrolysis of an acetal. And for test number 2, you learned the general reaction, acetal, ketal, acid and water. Get back to the aldehyde or ketone you would have used to make that acetal or ketal, plus the alcohol you would have. Now, in carbohydrates, the alcohols connect to the aldehyde in glucose. Again, you should know, instant replay, how to describe with words and a general reaction when you eat a carbohydrate. What's the key functional group in a carbohydrate? Acetal, your stomach, acid and water, and that's acid hydrolysis of an acetal. And here we have acetal, acid and water. We get back the aldehyde or ketone we would have used to make that, plus the alcohol you would have used to make that. And with that, I'm done with the review for test 4. Remember, test 4 I'll be giving this Wednesday. Any questions? I'm all ears. Actually, I got to shrink them. You know, the ears are the only thing after a certain while when you get older, keep on growing. All right, since there are no questions, let's continue on. And you can tell it's the end of the semester, Dr. White's getting lazy, which I can, organic chemists can. And here's the carbohydrate practice problem. What's a carbohydrate? See notes. Yeah, I was lazy. It's a polyhydroxyl aldehyde, polyhydroxyl ketone, or a molecule upon a hydrolysis that becomes a polyhydroxyl aldehyde or ketone. Now, I don't know, 2 points each. Is each of the following chiral or achiral? Remember, chiral, non-superimposable mirror image. Achiral, superimposable mirror image. Here's a secret. If you see the word left or right in something being described, immediately you know it's chiral. And a left foot, and if you don't believe me, you have a mirror at home, put your left foot in front of a mirror, you'll see your right foot. And if you try, your right and left foot are not superimposable. Chiral, mitten, no leather palm. Achiral, same thing with a tube sock. Sewing needle. Remember the great artwork I did in that? A piece of rice. It would have a superimposable mirror image. Now, baseball glove, that one, there's right and left. So if you think about it, a baseball glove will only fit on one hand, so it's chiral. Your face, well, didn't we do, Dr. White says, touch your right cheek, and you could. And that means your face is chiral. Also, it has a non-superimposable mirror image. You do the whole thing in 3D. And finally, a car. Remember that great artwork? Don't laugh too hard. It's chiral because it has a non-superimposable mirror image. Now, circle the chiral carbons in the following. How can you? How can you tell quickly what to omit? If a chiral carbon if a chiral carbon has two or more of the same group, or I shouldn't say chiral, if a carbon atom has two or more of the same group or atom, it can't be chiral. So immediately in this example, I can cross that off, that, and that. If a carbon is in a double or triple bond, whether it's a carbon or oxygen or nitrogen, it's out. So those are out. And the only thing left to look at is this carbon right here, hydrogen hydroxyl group. I'll call that methyl group R, this whole thing R prime. And it's got 1, 2, 3, 4 different groups or atoms. And I would circle it, and let's use blue, and that would be a chiral carbon. Now, if we go back and look at the examples, you can see on A, this carbon with the chlorine and this carbon with the chlorine and the hydroxyl group are the only two that can be chiral. In B, same thing. If it has 3 hydrogen or 2, it can't be if it's in a double bond. And the one with the thiol functional group SH is chiral. Now, let's look at D. And if we look at D, remember in a ring, this carbon, how many bonds to it? 2. How many bonds to carbon? 4. 4 minus 2 equals 2. So this has 2 hydrogens. This has 2 hydrogens. This has. So these are all out. Because if a carbon has more than 1 hydrogen or same atom or group, it's out. Same thing with the methyl group. That leaves us these 2 carbons. Each one has a hydrogen. But let's look at this one, hydroxyl hydrogen. I could say these and that would be 4 different groups or 4 different atoms or combination. So this would be chiral. And if I look at the other carbon, this has a hydrogen, methyl, these 3 carbons, and these 2 with the hydroxyl. So that's 1, 2, R prime, 4 different groups, 4 different atoms, or in this case, a combination of 4 different groups and atoms. So that carbon would also be chiral. And if we look at E and F, the aldehyde CHO, that's really a double bond to oxygen, a hydrogen on the carbonyl carbon, that can't be. This carbon at the bottom has 2 hydrogens that can. Remember, in a Fisher projection, every intersection of a line is a carbon. So these would have 4 chiral carbon. Same thing with this one, F. Now, next problem, draw the enantiomer of the following molecule, which means draw the mirror image of this chiral molecule. And if we look at A, I like to put in my little dashed line my mirror. What's closest to the mirror, you see first, then the second, the hydrogen is farthest away. Remember, the carbons here, H and OH, is coming towards you, and the aldehyde in the second carbon is going back from you. This is not a flat molecule. So you can't rotate a Fisher projection to see if it's superimposable. Now, there's a mirror image. Oops, cross off B. I got, ooh, when I wrote this, oh, let me do this. I don't do this anymore. Cross off B. And C and D are also mirror images. Now, this is a little different from the problems I've done before. Give the organic product or products for a following reaction. No, you'll be given, well, I'm not going to give this structure of glucose and fructose anymore, but you should know if it's an aldehyde you're getting, it's glucose. If it's a ketone, it's fructose. That much you should know. You can write the names, you don't have to draw it. Let's look at A. What do you get when you react fructose and glucose together with acid? Sucrose, table sugar. What do you get when you add glucose with more glucose and acid? Starch. Now here, when I did this problem set, I wasn't as good with my software in getting that arch. There shouldn't be a bend here in the line, should look like this, but you'll see on test number 4, this was a number of years ago. How long ago? Whoa, over 10 years ago I did this. Anyways, it's still good. What do we have here? What's different? Acid and alcohol and water. Acid will not react with alcohols, but it will react with a hemiacetal, ketal, this reaction, to replace the hydroxyl group with the OR triple prime. Everything else stays the same, and that's what's changed. OH becomes OR triple prime. And the carbon with the hydroxyl group is the carbon with the oxygen bonded in the final acetal right here. And here are the cyclohexane ring. Now, some reactions, sucrose, acid, and water, like in your stomach, you get back glucose and fructose. Starch, acid, and water, you get back glucose. Cross off G, because I really didn't talk about amylose, but that's just a starch, and you get glucose. That was a lot. All right, any questions about the carbohydrate problem set? Well, in that case, this would be a good time to take a 5-minute break. I think we all could use it. And I'll see you in 5 minutes and we'll continue on. Let's get comfortable too. All right. All right, a couple of quick things I forgot to mention earlier. Next, not next. If you should have gotten a review, online review for this class, please fill it out. Also, if you like what I've done this semester, go to ratemyprofessor.com and put something nice. If you didn't like what I did this semester, go to ratemyprofessor.com and put something, I guess, not nice, but I'd appreciate if you do that. All right. Last chapter, we've talked about carbohydrates. We talked about fats and oils. What's left? Proteins. And I've got to open that. All right, the material in chapter 17, amino acids, peptides, and proteins will not be on test number 4, but I'll have a few points on the final. So this is stuff you need to know for the final exam. Now, what's an amino acid? Now, an amino acid is short for an amino carboxylic acid. They just knocked out the word carboxylic and called it amino acid. Now, an amino acid is a compound that contains both an amino group and a carboxylic acid group. Here's one way of drawing it. A better way is this. Why did I do it there? Well, don't ask. This is an amino acid. And if you notice, like I've taught you all the semester, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, should have got your attention like that. And notice we have an amine group. And when an amine group is on a molecule with another functional group, it's called an amino group. And we also have our carboxylic acid. Now, as you learn for ketones and aldehydes, the carbon atom attached to the carbonyl atom is called the alpha carbon. And in all amino acids, the amino group is on the alpha carbon. I'll say that again in slow motion. In all amino acids, I'll speed it up. The amino group is always on the alpha carbon, the carbon atom attached to the carbonyl atom of the carboxylic acid. And this is an amino acid. Now, you just learned, or we learned before, chirality, non-superimposable mirror image. What's a chiral carbon? A carbon that has 4 different atoms, 4 different groups, or 4 different atoms and groups in combination. And if we look at this amino acid, oh, I'm getting all choked up over that. R group, amino group, hydrogen, carboxylic acid, 4 different groups. When R is not hydrogen, and it can be. So when if R was hydrogen, then there'd be 2 hydrogens. That couldn't be. But all others, amino acids, this carbon is chiral. And that's important. Like things like our RNA and DNA. Well, yeah, that's really important. But we won't get into that in this class. It's not biochem. All right, so the alpha carbon of amino acid is when the alpha carbon is bonded to 4 different groups. When R is not hydrogen, by the way, that's called glycine, which is not chiral. All other amino acids are chiral. And therefore, amino acids can exist just like your hands. They're antiomeric forms. Right and left, mirror images. Now, as I've mentioned numerous times in this class, Wikipedia, when it comes to anything chemical, especially organic chemistry, is spot on. It's been policed by people like me, and I have, because I have the credentials, that if I ask a change to be made, they are. But it's been a long time, years, since I've seen a major mistake. And here in amino acids, and you don't have to know them, but let's look at a couple right here. You see the different ones they have here? And each one, like in lysine, aspartic acid, if we go back down here to cysteine, if we go down bottom, alanine, leucine, each one of those on the alpha carbon is the amino group. Now I'll explain why the NH3 plus carboxylate anion minus in a little while. But each of these are the building blocks for something I'll teach you today. Not the organic part of it, not biochem. So amino acids, carboxylic acid, alpha carbon, it has an amino group. And except when, let's see, they have glycine down here. Glycine right here. You see right here on the alpha carbon, there are 2 hydrogens, because you know there are 4 bonds to carbon. You have a carbonyl and a nitrogen. The other is going to be hydrogens. That's the only one that's achiral that I know of. There might be another one, but essentially, I think all of them are. Now, let's talk about, and the switch is off, click for this slide, but other classes may need to know this, so I'm going to teach it to you. Let's talk about the acid-base property of amino acids. Amino acids, interesting enough, and let me write this to general form up here. Oops. Here's the alpha carbon. You have an amino group, and you know that's a base, and you have a carboxylic acid, and you know that's an acid. Now, how do they exist? Well, it matters on the pH. Now, if you're at neutral pH, again, switches off for this slide, the amino acid exists as what's called a zwitterion. And zwitter, I pronounce it the German way. Let me see if I can say it. Zwitter, no. Zwitter ion comes from the German word zwei, 2 ions. And at pH 7, this acidic proton is accepted by this basic nitrogen to form the zwitterion. Zwitterion means you have both a plus and minus charge in the same molecule, but overall net charge is 0. And this is a very important aspect of amino acids. That means that pH near 7, they can exist with these ions, which makes it ionic, which makes it water soluble, which means your blood can transport it places. all good things. Now, I won't ask you again, switches off. A zwitterion is a molecule that has a positive charge in one atom, negative in another, but no net charge. As you can see here, +1, -1, 0 net charge. Click, switches back on. For test number 3, no. Yes, I take it back. You learn this reaction. Take a carboxylic acid, react it with an amine. Remember, R prime and R double prime, one, both, or none can be hydrogen. And you form an amide. Well, an amino acid, notice I went Technicolor on you. Boy, did I get fancy on this one. You have the carboxylic acid. You have this amino group. And here, this R is, I'll call it R prime, of up here. And you form an amide. Well, here is your amide. And Mother Nature created a molecule that can react with itself or other amino acids to form a polymer. And notice on this molecule, I have 2 amino acids joined together. 1, 2. They can be different or the same. R, this could have been R prime if I want, double prime, or whatever. I didn't, I had it the same. And you still have an amino group here that can react with more amino acids. You have a carboxylic acid that can react with more amino acids. Now, if you're a peptide chemist or a protein chemist, the bond between amino acids are called peptide bonds. Now, Dr. White is not a protein chemist. The only protein chemistry I've done was with the meat I had yesterday or other things, soybeans, that had protein in it, or what my body is doing to make muscles. I like that muscle. Anyways, I will call that bond an amide bond because I'm an organic chemist, not a protein chemist. But if you're taking other classes, this amide bond is called a peptide. Let me see how to spell it because I never used that. But the key thing you should know is when you take 2 amino acids, amino acid 1 and 2, you form an amide linkage between the 2. Those are taking notes. I'll give you time to write this down. All right, everybody caught up? Give me a thumbs up if you are. All right, let's move on. So switches off, but again, for other classes, you might need to know this. Protein chemists call a peptide a molecule containing 2 or more amino acids in which the amino acids are joined together through an amide bond. Protein chemists call it a peptide bond, just like I showed you before, except there are two or more, that would be a peptide. Again, switches off for this slide. Switches off still. Protein. What is a protein? Well, that's a peptide in which at least 50 amino acids are present, connected together by what I call amide bonds, but protein chemists call peptide bonds. So what's a protein? It's just a polyamide polymer, even though protein chemists wouldn't call it that. I'm an synthetic organic chemist, I will. And what's holding each amino acid together is the amide linkage, called the peptide bond. This right here in red. All right, switches on, big time. Well, what happens in your stomach after you chew? Remember, I told you when I was little, my mother said, don't forget to chew your food well before you swallow or you'll choke. And when I was about 2.5, 3, I found out she wasn't lying to me. By the way, I survived, in case you were wondering. But when you consume a protein, your stomach and intestines, and somebody correct me which one, a couple of classes ago, and I forgot, small or large, breaks down proteins to amino acids by acid hydrolysis of the amide bond. And here's the general reaction you learn. Let me write it the way I actually did. Now, in your stomach, and this is one of the miracles of life in my mind, I have and you have cells that create hydrochloric acid, HCl. And if you've been doing what my cardiologist reminded me I should be doing, keep my heart healthy and my blood working well, drink a lot of water, in your stomach there's water and acid. H plus, HCl is an acid, hydrochloric acid. And as you learn for test number 3, you get back the carboxylic acid plus the amine salt, because in the presence of base, the amine you form immediately reacts to form the amine salt. And you get this. And remember, R prime can be hydrogen. Now, in amino acid, the amine and the carboxylic acid are connected together. So for a peptide or amino acid, you should be familiar with, if I take an amino acid, react it with hydrogen chloride, add hydrochloric acid and water, I'll get back the amine, salt, or the carboxylic acid plus the amine salt. Now, because you're in base acid, this amine also, as you learn for test 3, amines will react with acid to form the amine salt. So in your stomach, you're forming the amine salt of the amino acid, which helps make it more water soluble. It's polar. And you learn like dissolve like. All right, instant replay. Now, what's an amino acid? It's a molecule that has a carboxylic acid, and on the alpha carbon, the carbon attached to the carbonyl carbon of the carboxylic acid, you have an amino group. Hold on, time out. Think about what I just said. 6 months ago, would you know what I said? That's on the carbon attached to the carbonyl carbon? Most of you know. Think about how much you've learned in our short time together. You now know more than most people on our planet about organic chemistry, which I think is quite important, but then I'm biased, I'm an organic chemist. All right, time back in. You should know that an amino acid has this general structure, and the alpha carbon is not chiral when R is hydrogen, but when R is anything, 1, 5, or whatever carbons, this alpha carbon is chiral. You should know that. Now, on zwitterions, I turned the switch off, but for other classes, you might want to learn that. And how do you react two amino acids together? It's forming an amide linkage. Carboxylic acid, an amine, and I forgot to write down here, R prime and R double prime can be one or both or none. Hydrogen, in this case, one of them is, the other is this hydrogen. When you look at this nitrogen, and you form this amide bond in red, and that's a way of linking two amino acids together. So in our daily life, your skin is a protein, and it's made up of amide bonds. I talked about, and switch was off, you have a peptide bond. That's really what protein chemists call this amide bond right here. They call that a peptide bond. I don't, because I'm not a protein chemist. I don't think I know any protein chemists. All right, now peptide, again, switches off, where you have two or more amino acids joined together by an amide or peptide bond. And a protein, which is really a polyamide polymer, is a peptide in which you have 50 or more amino acids bound together by amide bonds, which is peptide. Now, digesting a protein. When you eat a protein, what's in your stomach is hydrochloric acid and water. And what's holding the amino acids together in a protein? An amide, also called a peptide, but I like calling it amide because it helps you understand what's going on. And here, as you learn for test number 3, if you take a amide, acid, and water, you get back the carboxylic acid plus the amine salt of the amine you would have used to make that amide. Remember, R prime and R double prime can be hydrogen. So for a peptide or an amino protein in your stomach, acid and water breaks it back down to these amino acids, but since it's acidic, the nitrogen is an amine salt. All right, for the final, for leaving my class, you should know how to describe, let me be subtle. You should know how to describe with words and a general reaction what happens when you eat a protein. Did I get that spelled right? Hold on, I'm going to cheat because I always get the I and E switch. I think I got it right. Wow, write that down in your diary. Dr. White spelled, I did. All right, back to chemistry. You should know how to describe with the words in a general reaction what happens when you eat a protein. Well, in your stomach, there's acid and water. So it's acid hydrolysis of, and what's the key functional group that holds amino acids together in a protein? An amide. That's why I don't like saying peptide bond, because this lets you know what functional group. And what general reaction you learn for test number 3. If you want to, you don't have to. I will. Our prime and our double prime can be hydrogen. And you get back to carboxylic acid plus the amine. Nope. Let me give myself more room. Plus the amine salt of the amine Therefore, this is the general reaction, amide, HCl water, you get back to carboxylic acid, and the amine salt of the amine you would have used to make that amide. In this case, it would be a protein. Now, a couple things. If you look at the lecture or practice problems, there are no practice problems for this. Why? Well, what can I ask you? Well, what's the key functional group in a protein? And I'll give you 30 seconds to think about that. Time's up. And the answer is an amide is the key functional group that holds amino acids together in a protein. Now, another one I could have asked you is, broad amino, chiral amino acids, no R groups, please. Your turn. All right. Well, remember the general form of an amino acid is this. But it says no R group. So R has to be anything but hydrogen. So I could have put this one. This would be an example. This carbon is chiral, methyl hydrogen amino carboxylic acid. I could have, I don't know if it exists. I really don't know if this exists because I'm not a protein or amino acid chemist. Here I put R as a benzene ring. And again, this alpha carbon, hydrogen, amino group, carboxylic acid, benzene, it would be chiral. Now, the last thing I could ask you, and you should know, how to describe, leaving my class with words in a general reaction, what happens when you eat a protein? And that's acid hydrolysis of an amide. The key functional group you should know that holds amino acids together in a protein is an amide. And in your stomach, you have acid and water. And the general reaction that you learn for test number 3, amide, acid, and water, you get back to carboxylic acid plus the amine salt of the amine you would have used to make that. Now, it just so happens in an amino acid, they're connected together. You have different amino, different R prime and whatever for the different amino acids that make up a protein. Now, what's a key protein or in your life? Well, I don't have too much left, but your hair and your skin. Now, if you had been in face-to-face, there were 2 labs we used concentrated sulfuric acid, and one of those labs we also used concentrated nitric acid, H+. And if you had been face-to-face with me, you would see I would be at DEFCON 1. If you don't know what that is, read some of the Clancy novels like Red Storm Rising. DEFCON is the system the United States uses for the level of preparation for its atomic bomber force and submarines. And DEFCON 1 has been described as having a gun. I hate to use a gun analogy, but this is the best one. And you're pulling your finger back and the hammer is all the way back and about ready to come forward. So in a lab with acid like that, I'm trying to look at every student to make sure they're safe. Why? Your skin, it's a protein. Amides, you get acid and water, just acid, concentrated acid on your skin, it breaks it down quickly. And you don't want that to happen. I don't know what it does to the nerves either. Unfortunately, years ago at the other school, the same lab I teach here, one student didn't follow directions using a funnel, tried to get it in a little opener with an eyedropper, and he was nervous, and he squirted on his arm. And now when we do it face-to-face, I have students wear a long sleeve top or a lab coat, or they can't come in the lab. That cloth protects you if you do get a little acid. But I warn people, I keep my eyes open because I am at the highest level of alert you'll ever see, Dr. White, me. And that person, even within 30 seconds, I was near when it happened. I didn't see it. I heard him scream though. Got him under a faucet, water on there. His arm looked like after 30 seconds of cold water, I looked at it, it destroyed the skin so bad. It looked like, and don't do this ever, like if you took a piece of hot metal and slammed it on there. That's why they call it an acid burn. It was just like if you burned yourself with high heat. All right, now I think I might have mentioned this, but we got time. Oh, do we have time? You're gonna get out early today. Everybody stop sharing. But anyways, when I bought this house many, many years ago, I've been here a long time, great house, great neighborhood, great neighbors, but when I bought this house, and I might have told the story, but I'll also add to it. Um, Within about 2 weeks, my kitchen sink stopped up, and that's got probably grease in there. Now, if your bathroom sink stops up, and that's happened to my sister and other students who have long hair, not like Dr. White. Well, I used to, don't think of this, but in high school, not high school, college and grad school, I had a ponytail. My hair was down to here. Don't think of that. But anyways, boy, was I a hippie looking hippie. But anyways, I had the rooter guy out. He cleaned it out. Day or two later, maybe a little 3 days, clogged up again, called him because he had a guarantee. Oh, I'm sorry. He came out, cleaned it out. All right. And then he came out a third time because the clock, I'm going to use this stuff. And I looked at the chemical and saw it was surfactants that won't touch the grease in there that well. And he did it. And a couple days later, guess what? It clogged up again. So I went over to my local Home Depot in Schaumburg here, and it's really good on the corner of Schaumburg Road and Barrington Road. I've been going there for many, many years, and it's always been great people there. And there's a whole wall of drain cleaner. I'm looking, what do I buy? And the name brands you all, Drano and others. And the gentleman who works there came up to me and said, can I help you? I said, yes. Of all these drain cleaners, which one do the plumbers use? And immediately, within 2 seconds or less, he points out the only bottle on there that's in a plastic heavy bag. On the bag, it says, please use proper eye protection when using it, is the hair and grease. Now, I picked it up, and the other bottles, which I had looked at before he came to me, all had hydrochloric acid in them. This one had sodium hydroxide and potassium hydroxide, base. And I said, oh, this has base. And he said, no, that's an acid. I said, sir, I have a PhD in organic chemistry. Many years, that's a base. He said, no, it's an acid. I finally realized, why am I arguing with someone in Home Depot who helped me out, I think? What's an acid? What's a base? When he's not a chemist. So I thanked him, took it home, and it worked. And I keep a bottle, and about 10 years later, it clogged up a little. I used it again in about another 10 years. Yeah, I've been here more than 2 decades. My house, like I said, I like it in the neighborhood and to my neighbors. It did it, and I used it again. I keep a bottle in the house always. And I used it also about after being here 18 years, my bathroom kitchen sink and my main bathroom tub. And I've had students who have had the tubs. Why am I talking about tub or bathroom sink? Because it's your hair, and the base does base hydrolysis of an amide. But I also learned never argue chemistry in Home Depot. It's a no-win situation. All right. Let's go back. Leaving my class, you should know how to describe with words and a general reaction what happens when you eat a fat or oil. I'll give you some time, then it'll be my turn to do it. How do you describe with words and a general reaction what happens when you eat a fat or oil? You should know this for test number 4. All right, let me give one more person a little more time to finish. If you don't know, just say yes so I can get moving forward. There we go. Thank you. All right, how do you describe words or general reaction? You should know what's the key functional group in a fat or oil. That's an ester, and that's acid hydrolysis. That's a Y of an ester. And for test number 3, you learn ester, general reaction, acid, water. You get back the carboxylic acid plus the alcohol you would have used to make that ester. So you should know how to describe with words in a general reaction what happens when you eat a fat or oil. As acid hydrolysis an ester, because the key functional group in a fat or oil is an ester. And here's the general reaction you learn for test number 3. Now, you should know how to describe with words and a general reaction what happens when you eat a carbohydrate. Your turn. And generally, even face-to-face, this last lecture on Monday before test 4, I usually let the class out early. So I'll let you out before midnight. And what's the key functional group holding glucose together in a carbohydrate? And acetal. So in your stomach, you have acid, and because you have water, it's the acid hydrolysis. And the key functional group holding glucose together is an acetal. And for test 2, you learn, and I'll use some metrical acetal because it's how you learned it for test 2. Acetal, ketal, water. You get back, keep your eye on the carbon with 2 oxygens. That becomes a carbonyl carbon. You get a ketone or aldehyde plus the alcohol you would have used. You don't have to put the 2 there, but for those who get bothered that it's not, should be 2. I put it there because I don't want bothered students. Not good. Anyways, acid hydrolysis on acetal gives the ketone or aldehyde plus the alcohol you would have used to make that acetal or ketal. And finally, you learned today, you should know how to describe with words and a general reaction if I can spell it right, when you eat a protein. Why don't you give it a try and then I'll do it. What's the key functional group that holds amino acids in a protein? Begins with the letter A, and it's not acetal. It's not alcohol either. And please be patient. I try and give everybody is finished. Still, please be patient. All right. What's the key functional group in a protein? And that's an amide, which protein chemists call a peptide bond, but an amide. That looks better. So in your stomach, there's acid and water. So it's acid hydrolysis of an amide. And for test 3, you learn, take an amide, and the stuff on proteins will be on the final, not on test 4, but I thought I'd cover it. In your stomach, you have hydrochloric acid, water. Remember, and you don't have to put this down, but I will. Acid hydrolysis of an amide gives you the carboxylic acid you would have used to make that amide, plus and you don't have to put charges, but I will. You get the carboxylic acid plus the amine salt of the amine you should have, you would have used to make that amide. Again, the amine salt, because an amine in the presence of acid forms the amine salt. Now, while we're talking about things you should know leaving my class, hint, you should know how soap works. Why don't you try writing down how does soap work? What's the general structure of soap? And don't forget to talk about micelles and important things. Your turn. Again, show the structure of soap, talk about micelles, and talk about other important things, how soap works. And by the way, next time you wash your hands, think about what I'm going to talk about, or you just wrote down, is actually happening on your hands. Yep, organic chemistry is everywhere. All right, my turn. How does soap work? Discuss the structure of soap. Soap has a nonpolar tail. And a polar head. Dirt is nonpolar, and you could put down grease too, but water is polar. And the key to the puzzle, so important, I'm going to another color. Like dissolves like. That means things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. And talk about my cells. You have a little piece of dirt. Since dirt is nonpolar, it attracts the nonpolar tail of soap when you're like washing your hands like this, or whatever you're washing. And I'll just put a couple of soap molecules and it forms a micelle. And a micelle with the polar heads all around on the outside of dirt I hope everybody knows water is H2O. I hope so. Never thought of asking that. But anyways, and now the micelle looks polar to water and they go down the drain together, and they do. And this is something you should know. And the next time you wash your hands, think about you're making micelles. And that's how you get the dirt off. What would be the product or products of that reaction? Glucose in that equilibrium. Your turn. All right, my turn. What do we have here? On C5, we have an alcohol. Up here, we have an aldehyde. And the general reaction to learn for test two, when it's inter between separate molecules, not like this is in the same molecule, you need an acid catalyst. Keep your eye on the carbonyl carbon. That's where the fun is. this oxygen attacks that carbonyl to form that bond, opens it up. Now, what's not involved in the chemical reaction, you learned you don't break carbon-carbon single bonds. I'll just rewrite. Now, this carbon right here becomes this carbon. And now this hydroxyl group attacks the carbonyl carbon and forms a carbon-oxygen bond, this right here, and that's how you do it. And let's do one more. Either draw the structure or write the name of the product when you react fructose and glucose together with a little acid, otherwise known as an enzyme. Most, not all enzymes, now I'm going beyond my knowledge of biochemistry, I was told years ago, were acid catalysts, most, not all. And please be patient. I try and give everybody time to finish. I should have a recording made up of that so I can just press a button on a tape deck or and play it back. It's a generation gap. How many of you have ever seen or you had a tape deck? I had a couple good ones years ago. All right. What do you form when you react glucose and fructose together? Sucrose, table sugar. And that's what you get. All right. One of the things I mentioned a couple of times in this class, because we're not face to face and we didn't go into laboratory, but you did learn laboratory experiments. On Wednesdays, I stole extra time. And because of that, this semester, you got a lot more examples like I used on Wednesdays to practice and learn organic chemistry. So even face-to-face this last lecture, the second last week, I'll let class out a little early. Now, a couple important things. On Wednesday, I will be giving test number 4. I gotta get that fixed one of these days. Also, remember, on the 8th, if you want to do it, the extra credit project is due. And if you want, before then, email me what you plan on submitting, and I'll check it over and tell you what you have to correct. Also, I have my office hours on Tuesday and Wednesday from 6 to 6:15. If you need any help, stop by. Don't forget the lab we did yesterday, the one with the bubbles, is due this Wednesday. And finally, I can tell you, the first day of class, I said my world of organic chemistry is your world of organic chemistry, but you don't know about it. And now, my world of organic chemistry is your world of organic chemistry, and you do know about it. You know more about organic chemistry than most people on our planet. And hopefully that's a good thing. I think so, but I'm biased. With that, I'll remind you on Wednesday, you don't want to miss class. I'll cut it out of the video and I won't repost it. I'm going to do something very special. Few people have ever seen. It's legal. But anyways, you'll enjoy it immensely. and we'll do our lab. And with that, I'll say, gehen gesund, goodbye.